All right. Let's have a look at transformation of trigonometric function, vertical equilibrium, vertical and horizontal, which is phase. All right. So, vertical shift equilibrium is just moving translating the trigonometric function in the direction of positive or negative y direction. Phase shift is translating the whole graph in the negative x direction or in the positive x direction. Alright? Now, so we need to be able to derive and graphically formalize the complementary relationship of sine cosine using horizontal translation of the sine and cosine function. This is called phase shift identity. So you can see that by doing so, sine can become cosine, cosine can become sine. Alright? You must be able to compare the graphs of sine, cosine, and tangent functions with phase shift changes and describe the maximum and minimum points of the trigonometric functions over a given domain. Also, you should be able to sketch the trigonometric function. Alright? Now, recall for any function f of x, when we've got y equals to f of x plus d, d defines a vertical translation, d units in the direction of positive or negative y-axis. Alright? So if d is greater than 0, you move up, which is in the direction of the positive y-axis. If d is less than 0, you move down, which means it is in the direction of negative y-axis. So think of this as a transformation, as a change of the equilibrium. You know the equilibrium for sine cos function is actually 0. So that point y equals to 0 is moving up or down. That's the important thing. Alright? Think about that, moving up or down. Now, on the axis provided, can you actually sketch the following domain for 0 to 2 pi? Alright? You need to think about how you would sketch sine x minus 1. The first thing I would actually do, is sketch sine x first. Alright? You know sine x minus 1 means the whole of the sine function is actually translated in the direction of the negative y-axis by 1. So start off with, of course, you need to label the graph. That would be pi, 2 pi. Did I do? Yep, 2 pi and pi. Alright, so let's say this is 1 and this is minus 1. Always start off with the sine curve. So you know when sine is, when x is 0, y is 0. Alright? When x is pi over 2, sine x is 1. And so on and so forth. Alright? Start off with this. I use a dotted line to make it clearer. Alright? So this is y equals to sine x. Now, look at the important point. Alright? Starting off with 0, 1, and 0, minus 1, and 0. What I would do is, I would actually just translate it down by 1. So this will be now minus 2. Alright? And your curve should look something like this. Y equals to sine x minus 1. Alright? This is probably the most straightforward. Okay? The most straightforward one. You just, as soon as you look at sine x minus 1, you know that you're translating it down. Alright? Let's go to the next one. Next example. 1 minus cos x. What does a minus cos x mean? Sorry? What does it mean? Reflected what?
The x-axis.
Yes, reflected by the x-axis. So again, what I'm going to do is I'm going to write down something carefully to show you. So here we know the amplitude. No change in amplitude is 1. But you need to reflect about the x-axis and then translate in the direction of the positive y-axis by 1. Or you can actually write it out this way. If you want to think about rewriting it, you could actually write it as minus cos x plus 1. So to make it a little bit more obvious, it's actually translating it up by 1 unit. So I'm going to start off again labeling 0, 1, minus 1. So this will be pi, this will be 2 pi. So when x is 0, start off with y equals to cos x. This is 1. Cos x is 1. And when x is pi over 2, cos x is 0. And so on and so forth. Alright? So you now have just dotted line y equals to cos x. Now, the next thing we do is let's do the reflection. Reflection. Oops. Use a different color. So reflection, this is reflected, it will be minus 1, correct? That still remains at 0. That will be plus 1. That remains at 0, that will be minus 1. So that's a reflection. I'm just going to plot 3 points. And that is y equals to minus cos x. Now, so you add 1, what happened? The whole of this will be moved up by 1, correct? Move in the positive direction by 1. So, what we do is, I am going to show a few points so that I can actually plot it properly. And this is now 2. So this is what the graph looks like now, the function. This is y equals to 1 minus cos x. Alright, now you can do, starting off with the way I've done it, which is start off with cos x and then minus cos x and then move it up. Or you can start off with just 1 point. Starting with this point, think about the reflection and move out. Starting with this point, think about the reflection and move out, and so on and so forth. You can concentrate on the important points only, or you can sketch the curve. It is up to you. Alright? As long as you label it clearly and show that this one is actually the final product you want. Alright? That's quite important.
Yeah, because you're changing the one.
Alright? Now the next one, tangent. How on earth am I going to do this one? Tangent. It's going to be interesting. What I'm going to do is, again, I'm going to write out something. Amplitude. Start off with the amplitude. Oops. Amplitude equals to 1. You know that the period is pi for tangent x. The rest, sorry? Period of tangent is pi.
No, but you said amplitude is 1.
Oh, no, amplitude is whatever. You don't need amplitude. What am I saying? You know that it's not amplitude. That's no whatever you call it, dilation factor for y. That's all. There's no dilation factor for y. Alright? So I'm going to get a ruler and going to do a few things because I need to show where the, whatever you call this, what the asymptote is. So starting off, let's label. I'm going for 0, 1, 2, 3, minus 1, minus 2, minus 3. All right? Now, yeah, you know the period is pi. That's no dilation factor for y. So period equals to y, pi. All right? No dilation factor for y. All right? And reflection is about the x-axis, and translation in the direction of negative y-axis by 2 units. All right? Oops. All right. Now, what I'm going to do is, again, label pi and 2 pi. All right? You know that there should be asymptote, correct? Around pi over 2, which is 90 degrees. Oops. And then 270 degrees. So I draw this so that I know these are the asymptote. So start off with when x is 0, 10 is 0. And then the other point is here. All right? When x is pi over 4, you know that 45 degrees, 10 is 1. All right? And then, next bit, the other point here, this will be minus 1, that will be 1. All right? Pi, 10 of pi is 0, 10 of 135 degrees is minus 1, and then that is positive 1 and minus 1. So what you need to do is be able to draw the graph like this. All right? Oh, I should use dotted line. Makes it a little bit easier, so that you know that this is just 10x. All right, it goes, oops. It goes from here. And for sure, this one will go this way. All right? So this is y equals to 10x. All right? The next thing I'm going to do is go straight to doing y equals to minus 10x minus 2. So let's think about this. Reflect about the x-axis. No reflection. Minus 2. I'll bring it down here. Correct? To minus 2. This point, reflect to here, minus 1. And then I'm going to move in the negative, in the direction of the negative y-axis by 2. So it's therefore this point. All right? Here, up, correct? Reflect, and then move down by 2. So it doesn't change at all. Still that point. Right? Do you agree? Do you agree? Yeah? All right? Very good. So this one, no reflection, but you're going to move it down by 2. Thank you. Reflection, reflect, and then move down by 2. Right? Agree? And then this one is reflect, move down by 2. No change. Reflect, move down by, oops. What am I doing? I want this one. All right. This one. And then move down by 2. All right. Oops, hang on. Wrong. What am I trying to do?
It's probably starts with
this. All right. So you can see that it will go this way. and it's doing something like this one, and then finally this one goes this way. Alright, so that is y equals to minus 10 x minus 2. So if you do it step by step, it makes life a little bit easier. You just follow all the steps that I've shown you. So you know B cat, what we're doing is now doing A and D. Alright? Next, you need to be able to identify the graph. Alright, that should be plus. Can you check that I have changed all your handout to be plus? I wanted it to be negative, but I did not plot it correctly, so I'm going to change it to plus. I'm just a little bit too lazy to change the graph again, so that's fine. So let's start off with 3 cos x plus 1. Alright? First, we look at the amplitude. Equals to 3. Then you know that it's translated in the positive y axis by 1 unit. Alright, so cos curve. Cos curve, we start off with somewhere here, correct? Which is when x equals to 0, cos 0 is 1. And then amplified by 3, 1 times 3 is 3, plus 1, and that becomes 4. So look at the extreme point, then we therefore know that this is y equals to 3 cos x plus 1. Now of course tangent is pretty straightforward. Look at the graph, you know that that is y equals to 9, 10, x plus 4. And then what is left is here. Sine 2x minus 5. You know sine 2x, what happened? Sine x. Sine x plus minus 5. So therefore you know that it's already gone up. And then you've got to move it down by 5. So that is y equals to, that is this graph here, y equals to 2 sine x minus 5. Alright? Pretty straightforward if you look at some of the graph. But of course, in the test, you may not get something which is as straightforward as this. This is just a warm-up. Alright, let's look at something else. Are you all happy with it so far?
Yeah.
Alright, let's go. Move on. Alright, can you sketch a function on the axis? Not below, on the side. Over the domain of 0 to 720 degrees. This time, when I start, we are going to go, instead of 1 rotation, there's the rotation. Now, here, I've given you the note. When you do something like this, identify the equilibrium, consider sine cos of 10 and amplitude to plot starting point, and then identify extrema using amplitude and period. So let's start off looking at this. What is a period? What is period now? You know period is, if I go from sine x, the period is 2 pi. What about sine of half x? Period is 2 pi over b, which is half. That's 4 pi, which is 720 degrees. Sorry? 720 degrees, correct? Sorry?
Yeah, but like, do you like have to do pi?
Yeah, makes life a little bit easier sometimes. 360 divided by
Isn't it
half.
more correct to do like degrees?
You can, it really doesn't matter. I like to use period equals to 2 pi over b. That's the definition. The reason why you're doing 2 pi over b is by the time you start modeling, alright, which is when we come back the modeling bit, everything will be pi. So get used to pi. Alright? Amplitude is 2, and you have to reflect about the x-axis. Alright? And finally, translate. in the negative direction of the negative y-axis by 3 units.
What did we do?
All right. Again, you start off with your basic cos curve, which is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. All right. So let's think about the equilibrium. It's actually 0 for cos curve, and you know it will look something like this. All right. Y equals to cos x. Now,
So it's sine. Because it's sine.
oh, sine, sorry.
Is that
Yeah, it is sine, not cos.
It doesn't start yet. If it started.
I did cos this year, sine, thank you.
Yeah, it starts at equilibrium.
It is sine. All right, that's better. That is y equals sine x. All right. Now the next thing you know that the period is now 720 degrees, which is 4 pi, which means we are only going to look at when we stretch the whole thing out, this bit will disappear. You're just looking at that bit, correct? So start off with the amplitude is 2. So the amplitude now we've got to multiply by 2 and then reflect. Correct? Multiply by 2 and then reflect. Let's start off from this point. This point. If it is 0, it doesn't change because 0 times 2 is still 0, and then down by 3. So that way. Next one. 1 times 2 is 2. 2 down by 3 is 1, 2, 3, which is here. Correct? Hang on. Have I done it right? No, actually no. It's amplitude 2, and then reflect 2 here, and then go down by 3. 1, 2, 3 is down here. My fault. All right. You've got that point. So practically every of this point will go in the same. Will have the same y coordinate. All right. So that will be here. And what else? Oops. Hang on. I also made a mistake, sorry. I did say to you, consider this bit only. All right? Consider this bit only. Here, you've got to multiply by 2 first. You've got to multiply this point by 2. So let's start off with this point. You've got to multiply this point by 2 because it's now 4 pi instead of 2 pi. So this is going to be moved across to here. All right? 1 pi over 4 multiplies by 2 becomes pi over pi over 2 multiplies by 2 becomes pi, which is 180 degrees. So from here, what you're going to do is amplitude going up here, and then reflect down to here, and then move it down by 3. So that is a point there. All right, you got 2 points already. And then think about this point again. 180 degrees. It should be the same as there, but it's going to move up to 360 degrees. Agree? And then we look at this point. This point multiplied by 2. We go with negative 3. Actually, multiplied by 2, 270 degrees. We'll go all the way up to 540. All right. So this point here will go up to here, and then multiply by 2 here, and then move reflected about the x axis going up to there, and then you move down by 3, which means this point will be here. And then finally, the last point, that should be here. So the graph now, function now looks like this.
That's scary.
It's a little bit more complicated in a way because you've got to think about the degrees. You've got to first think about the change in period. Once you've done the change in period, you think about the amplitude, and then reflect, and then translate. All right? Think about the most important thing, which is your BCAD. Start off with B, and then C, and then A and D. All right? BCAD. Remember your BCAD. Now, let's think about the horizontal translation. Given a trigonometric function, fx, we can say that y equals fx plus c, correct? It defines a horizontal translation, c units. C plus c is in the negative direction, moving that way. All right? Moving that way. And then minus c is positive direction, moving that way. So when modeling using waves, the horizontal axis is often related to time and pace, and time and hence a phase shift, which is the change in time. So in modeling, we always use pi. We always use radian. We never ever use degrees. We'll talk about modeling when we come back next term. All right? So we are going into the part that I think would be probably the hardest. All right? So you're thinking about how you shift in terms of time. All right? You can see that this has been shifted by maybe, if this is time, that would be about, if it is in seconds, it moved from here to here by about 25 seconds. All right? We're thinking about x as time. Now, a phase shift alone does not change the amplitude or period. However, you need to know, remember BCAD. BCAD is important. How we're going to change B, the dilation factor, in the x-axis, or apply to x, start off with the dilation factor, and then the phase shift, and then think about the amplitude, and then think about the moving up and down. All right? Now let's need to think about making sense of complementary identity. The complementary identities. Sine is actually sine of pi over 2 minus theta equals to cos theta. And cos of pi over 2 minus theta equals to sine theta. Now, the focus question is, what do you do? What do you need to do the sine curve to transform it to a cos curve? And how do you transform a cos curve to a sine curve? All right, think about, let's go back. What happened? If it is plus c, negative direction, that way. Minus c, positive direction, that way. So here, if I want to change this curve to this curve, how on earth I'm going to move this point? Am I going to move it there or move it there? Same thing. How on earth I'm going to move this down? Here or back there? Which way? What do you think? So what we want to do is we want to change y equals to sine x to cos x. All right? Now, if I use something like this, sine of pi minus 2 minus theta, so sine. How are we going to move it to cos? Which direction are we moving? That way or that way?
Left.
Which way? So think about it, this is going to move down here. You're going to shift it in the negative x direction, correct? Yeah? Yeah? So shifting it that way, in that direction. So how many pi over 2 that we are needed to add to this? Or take away from this? Plus or minus?
Plus.
Plus. So therefore, you have got to change that. y will therefore equal sine of theta plus pi over 2. You are moving from this point here, pi over 2, back to here. Can you see that it has shifted the whole trig function in that direction, which will become this? Agree? Yeah? Agree? And then what about from cos to sine? You're going to move from here to that direction.
Yes.
Correct? Yeah? So y1, y equals to cos x to sine x. So therefore, y is therefore cos of theta minus pi over 2. Alright? Think about how you're going to move. This time you're going to move here to there. Alright? That direction. Use the maximum point to help you move. Alright, next bit. Now, let's think about the supplementary identities then. Supplementary identities, the two angles add up to how many degrees?
180.
180 degrees. So, again, how on earth are you going to move this? Alright? How on earth are you going to move this? And how would you translate that? So can you actually write down 6 true statements about phase shift, sine, cosine, and tangent? In terms of graphs, 180 degrees in either direction, whether it's left or right. How are you going to move this to left? How are you going to move 180 degrees to right? So if it is sine, when are you going to move? How are you going to move 180 degrees to the right? How on earth are you going to move 180 degrees to the left? Alright, use that to help you. So if I want to move 180 degrees, sine theta plus pi. Now, it will be equals to negative sine theta. Correct? So you are now transferring sine theta. If you want to move sine theta, which is the red curve, by plus pi, it's moved all the way here. What happens? That comes over to here. The red line, this bit here, this part here is now that. Correct? Isn't that the reflection of this? Agree? Hey, both of you. Isn't that the reflection of that? Correct? Yeah? Can you see it that way? Yeah? Now, what about if I write sine theta minus pi? Which way are we moving? Oh, hang on. Plus pi is moving that way. Sorry, my fault. It's moving that way. So therefore, this has, you can see that it's that way. So it's a reflection. Whereas minus pi, we are moving this way. That's a reflection. Alright? So that is a reflection. Minus pi. That's a reflection. So therefore, sine theta minus pi equals to minus sine theta. Alright? Same with the cos. If cos, you are moving that way by 180 degrees or moving that way by 180 degrees. So what happened? It will become minus. So cos theta plus pi will be minus cos theta, and cos theta minus pi will be the same as minus cos theta. So look at the green line. The green line here, alright, the green line here, alright. So this time, what I want is, I moved it by, doesn't matter positive or negative, by pi. So if I move this by pi, what happened? It will become this. Correct?
Yes.
Which is the reflection of this bit. Got it?
Yeah.
So therefore, negative is a reflection about the x-axis. Alright? And then what about tan? Let's have a look at tan. Tangent of theta plus pi equals to tangent of theta. Tangent of theta minus pi equals to tangent of theta. Now, basically, you got to think about this as what is the period? The period is 2 pi, whereas the period is 1. So what happens if I move this by pi? So this is pi. Alright, so when you're moving it by pi, so negative, it will move up to here. See? See that? And it's actually moving across, by pi is to here. My fault. By pi is to here. Does it change? Not pi over 2, by pi. So it doesn't change at all. So when you take away pi, tan theta will go from here to still the same point, correct? So there's no change. Because the period of tan is pi, whereas the period of sine and cos is 2 pi. All right, the next one. We are now moving to 2 pi. So if I move this by 360 degrees 2 pi, what happened?
Same.
It's still the same, correct? What about this? Is it the same by 2 pi?
Yeah.
What about here, if I move it by 2 pi?
Yes.
No.
What happened?
Oh, yeah.
It's still the same, isn't it? So if sine theta minus 2 pi, or theta plus or minus 2 pi, is still the same as sine theta. Cos theta plus or minus 2 pi is the same as cos theta. Tan theta plus or minus 2 pi is still the same as tan theta. Do you agree? Because you are moving by 360 degrees. So a whole rotation, it goes back to the same spot, whether it's positive or negative. Yeah?
For tan, wouldn't it be 1 pi?
Sorry?
For tan, wouldn't it be 1 pi?
It's still the same. 1 pi, no. It is the same, pi and 2 pi. Because you move up to 1 pi, and then another pi, 2 pi. Rotate 360 degrees. See that? So you start off with 1 pi. You can, if you move 1 pi, it's still the same. Alright? And then move 2 pi, it's still the same. So think about it, a whole rotation is 360 degrees. Got it? Now, example 6. I would like you all to think about how you would describe this. The amplitude, period, and phase shift for the following trigonometric function. Alright? Yeah, probably won't get a chance to go to example 8 and 9. You've got to watch the video. Alright, now, describing the amplitude, period, and phase shift. For the first one, let's think about the amplitude. What is the amplitude for the first one? It's 2. Alright? Now, what about the period?
Which part do you do?
2 pi over 2. Your b. You always have to factor it out. 2 pi over 2. So therefore equals to pi. And then the phase shift. Now, plus 40 degrees means which direction am I moving? Negative x. Phase shift in the direction of negative x-axis by 40 degrees. Alright? And then for the next one, we don't need to worry about amplitude. You know the dilation factor is 8 and then reflect by the x-axis. So we need to rewrite this. 10, 3, x plus pi over 3. Always factor the coefficient of x out so that you know this is the phase shift and that is your b. Use the format I show you. Always do that. So therefore we know the period pi, oh hang on,
D would be
2 pi over 3. Alright, the period is now 2 pi over 3. 2 pi over 3, because of that, you know that it is reflected
A is reflected.
about the x-axis and phase shift. Plus pi. Do I move left or right?
Positive direction.
Plus pi is negative.
Oh, yeah,
It's from
yeah. My bad.
that's not from but yeah, that's not.
By pi over 3. Alright, finally, this one, you must rewrite it. Cos 1 over 6x minus 180 degrees. So that you know that the period is 2 pi over 6, 1 over 6, oops, not 2 pi over 6, 2 pi over 1 over 6.
6 times 247.
2 pi divided by 1 over 6, which is 12 pi. Alright? And then you know that the amplitude equals to 5, and phase shift is translate
You would factorize the 1 over 6 out.
in the positive direction of the positive.
Or you just factorize, get factor out.
Positive x-axis by 30 degrees. All right. Now, like I say, I really haven't got time to go to. It's a long session, long lesson, and I haven't got time to go to example 7 and 8. The video link, I will upload it.
Yeah.
Before I finish off, I really want all of you to think about the BCAD. All right? Important, always we are doing BCAD. Always in terms of the x coordinate first. Think about the dilation. The dilation is 1 over b, and then the phase change. The phase change is either translating left or right. Think about how you would translate it, whether it's positive in the positive is in the negative x direction, and positive is in the positive is the negative x direction, and negative is in the positive x direction. All right, and then A, that affects the amplitude, that affects the equilibrium up and down. All right, so now, like I say, example 7. Oh, I can do example 7. Describe the transformation. How do you describe the transformation? Example 7. Let's start off with BCAD. All right, BCAD, what is B? B is dilation parallel. So, dilate. Always give the proper order. Dilate in the, dilate parallel. What should I say? Dilate parallel to the x-axis by a factor of 1 over 2. All right, that is B. All right, C, which is a phase shift, translate in the direction of the negative x-axis by 40 degrees. All right, and then equilibrium. Dilate parallel to the y-axis by a factor of 2 and then translate
Yeah, C is
um,
that's moved.
in the direction
What do you move? Why?
of the positive y-axis
Right,
by 1 unit. Alright? Always make sure you go follow the step. BCAT. I think the only one that we really don't do is reflect about the y-axis. Alright, we do reflect about the x-axis. Alright, I've got to stop here. It is a long lesson. Example 8. Please watch the video. This is how, example 8 is how I went through explain going from y equals sine x to this bit, which is y equals minus 2 sine x, 2x plus pi plus 1. Alright? Think about how you would do it. I have explained it very clearly in the video, as well as this example here. Alright, I'm going to stop here.